Hey everyone, today I'm doing 128 on Leetcode, longest consecutive sequence. This is one of my favorite problems, honestly, because the trick to solve this is it's really fun. So anyways, the problem statement is simple. You are given an array, nums here, and you are supposed to return the longest consecutive subsequence, or not subsequence, but sequence. So when we say sequence, we mean it can be in any order. We see in this case it's 4, and the sequence is 1, 2, 3, 4. So the problem statement's really simple. We're given all of the numbers. They don't have to be ordered. It's not a subsequence. And we just have to find the longest streak, basically. If you look in the solutions, they'll all call it streak. I like that word. Let's call it streak. Because it's the longest continuous chain of numbers. And we have to find that. So it's very easy to understand the problem, and it's very easy to solve this on paper or on a whiteboard. So that's going to be the trick here, is to leverage an efficient data structure to look these up in O of 1 time, and that should ring as like a hash set or a hash map, etc. So we can do exactly that. So the key here is we should step through this array, and if we ever can continue a streak, we should continue that streak. Now what I mean by this is we'll put all of these into a hash set. So assume all these numbers are now in a hash set, and this is the set. This is the set. And then we go back through these numbers, and now we have a mechanism to look up these numbers in constant time to see if we can continue a streak. So we get at 100. Let's see, so we're going to solve this a different way, but if you're doing this on a whiteboard, you would see, do we have 101 or 99? We don't, that doesn't exist, so we can't continue a streak, so the longest streak is 1. We get to the 4. Do we have a 3 or a 5? We do have a 3. Okay. From the 3, do we have a 2? We do. From the 2, do we have a 1? We have a 1. And we count that whole streak that we just counted, and the max becomes 4. We step through the other ones. 200, that's 1. It's not bigger than 4. We get to the 1. Here's the key. We already counted that streak. We should not count it again. And right here, this is the key from reducing the time complexity to n squared to just n, because we're not double counting any numbers. We're only counting each number once. And that's how we're going to get to on time complexity. So to do this, we need our set, and we need to add all the numbers to it. So let's have our set of integers, and this is going to be, we can call this scene. Not very creative with these names. So we have our hash set here, and this is our scene, and we can put all the numbers inside of it. I think we can do this. I can't remember. No, I don't think we can do that. You have to use a collector or something. So let's just put them all in, because I don't want to figure out how to do this, and let's go like that. So we put them all in, and we fill up the scene. So next we're going to need a few more things. We will need our longest streak, so our longest consecutive number, and that is just going to be our result here, and we can put this down a little bit. We know that we're going to return it at the end, and then we want to go back through the numbers, right? So for each num in nums. So the trick here is we want to see if we can continue the streak. So you could do something like num contains the number below it or the number above it, but let's just keep this consistent, because for there to be a streak, there has to be the last number in the streak. So we will just automatically assume, if there is a streak, that this number is the last in the streak. What I mean by that is if we have this streak 1, 2, 3, 4, when we get to 4, only then should we start counting. And how you know this is you can do this. So let's go current streak. So we'll go int current streak, and we know that it's 0. So while num is in scene, so while scene contains num, we're going to walk down the streak. So if we're at 4 right now, we're going to go 4, 3, 2, 1, and keep going down. So while it contains num, we're going to do two things. We are going to both increment the streak and also decrement the num. So this will keep going down the num, and it will keep counting the streak. So this is all good, and this is going to work. And in fact, you could even set the result to be the math.max, but this isn't going to prevent our double counting. So how we can do that is we can go like this. So result equals math.max result and current streak. So we want to make sure that we are at the tip of our streak. So we should go while scene.contains num and not scene.contains num plus 1. So this will ensure we'll be at the very tip of our streak and we won't double count any numbers. The problem is what if we do 4 and we go back to 3? Well, 4 is still going to be in here and we're going to count all those numbers again. So another thing we can do is remove it from scene because we know it's accounted for. I'm sure there's a better way of doing this, but I kind of like this way because it's very clear to understand what's going on. And let's run this, and looks like it's pretty good. And let's submit it. And yeah, hope this made sense. So to reiterate what we did here, we put all the numbers in a set so we can look them up in O1 time. We look for the tip of a streak, the top of a streak. And then once we get to the top of a streak, we count down until we don't have the streak anymore. And then we compare the streak to the biggest, longest consecutive elements. So let's talk about time and space. So space is obviously right away the easy one. We know that space is O of n because we're using a set and putting all the numbers in there. Time is going to be O of n as well. So you might disagree with this at first because we have a for loop and a while loop inside of it. But the proof that it's n is what we're doing with scene.remove num here. And we're only starting this while loop if we're at the tip of a streak. That means we're guaranteed to only count a number once. We're never going to double count a number, which means if we're only doing a for loop through each number and counting each number once, then it's just O of n. And that is why it works like that. And I hope I made this medium problem a little bit easier. So thank you for watching. I appreciate it.